Well, hello, and welcome back. For those of you that are joining in live, I'd like to let you know there is a link in the description, or should be, I hope, to the YouTube channel, which is where I've got the comments open, so I'll keep an eye on those. And if you are not watching live, also take a look in the description because you may find the edited version in the Beyond Code Bootcamp playlist. With that out of the way, let's go ahead and get started. Oh, there we go. Well, hello, and welcome back. So tonight we're going to do a quick one. We're going to talk about functions, just kind of briefly what they are and how they work, or at least the modern style of functions. And there's kind of two styles we're going to talk about. If at any point this video is useful for you, please go ahead and give it a thumbs up. And blah, 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 blah. Actually, I'm just going to redo that part, so forgive me while I redo that real quick because we're not even far in. Okay, I just flubbed it, my bad. Well, hello, and welcome back. Tonight, we're just going to do a little piece on functions, or at least the way that modern functions work, and we're going to kind of center that around two ideologies. Somewhat of a pure function, so to speak, as well as a method, as in an object-oriented method. And if at any point in this video you get that aha moment where something just kind of clicks for you, go ahead and give it a thumbs up and then leave a comment down below. Let me know what that was. Maybe put a time code on it as well. So let's get started. I'm going to do this in JavaScript syntax because it's the most popular language on the planet, and it works in a fairly modern way. So a function usually begins with a keyword that's something like function. We're going to call this one create because we're going to create something with this function, and we're going to pass in a color and a gearbox. Can you guess what we're creating? We're going to create a car, because the way that I'd like you to think about functions is as a process. Think of it as a manufacturing process. You have essentially a rule, which I'm calling this rule create, and it's got a number of steps to it, which we're going to insert in here. So if I was manufacturing a car, I would have the rule is produce a car, or the objective we could say, and the steps are create the frame, put the body on the frame. Well, no, we wouldn't do that yet. We'd put the seats in, we'd put the engine in, we'd put the body on, we'd put the tires on, and then we'd probably color it before we put the tires on, and we'd get it off the assembly line and out to the customer where it can be shipped out to the customer. And every time we run that process, we're going to get a different car than the previous car. The cars may be identical in terms of make, model, color, and options, but they are in fact physically different cars. They do not occupy the same space. If you reach out and touch one, you are not touching the other, or they're different. And I know this is obvious, but in programming, we sometimes forget that. So I'm going to extrapolate and show here. So let's say we're going to create a variable and we're going to call it car, and it's going to be an object. Actually, before we even do that, we're going to set some reasonable defaults. So if we don't have a color, we're going to say that the color is black. Get whatever color you want it, as long as it's black. And if it doesn't have a gearbox selection, then we're going to say that the gearbox is automatic. And we can imagine that this is an inventory listing for a car. Maybe we're writing the instruction that's going to go to the robot deck, and then the robot deck is going to assemble all these things and spray paint it and do all that stuff. So that's what we've got there. And one option that we don't have is that this car is going to be a Honda because this is the Honda factory. And another option that we don't have is the model because this is the Civic line. So everything coming out of this is a Honda Civic. But the color that could be changed based on what the person wants. And the gearbox that we put in, that could change based on what the person wants. And then we'll return the car. So don't get too caught up on all the details of this if you're not familiar with JavaScript. It's just the general concept that we're working with here, is that we have a function. It's basically a rule for some process. It has a name, and it accepts some arguments or parameters or options. All of those mean the same thing. And what we're going to do is, if there are not default options, which some languages require that you have default languages or default options, JavaScript does not require that. So we could have something that has no default option, and we might just want to check the exclamation here means not. So or rather inverse. So if color is nothing, it'll say if not nothing, which becomes truthy. And then color equals black, same thing here. And then we return it. So if I were to call this function, the way I'd call this function is I would say create red and manual. Red cars should be manual. And then I might, and we could do red car equals here. And we'll do a blue car. Blue cars play it safe, they're automatic. So each car would have its own make. They would happen to be the same, but they would in fact be different. Just like two cars coming off the lot might both have the same steering wheel in terms of it's the same type of steering wheel, but physically they're different. And in the computer world, that's kind of sort of true. It's mostly true because I will reveal a detail here. In a computer program, typically it will actually link the two together until they're different. I don't want to go into that, but just so that I'm not lying to you. But in terms of how you use it as an individual, to you will experience them as completely separate. So, for example, if I were to change the red car color, which we couldn't do after the cars come off the lot, but we'll pretend, no, we don't want to change the red car. The red car is awesome. Let's say we want to change the blue car color, and we want to change it to yellow. If we were to look at, let me create some extra lines here. If we were to inspect the red car and the blue car, the red car is going to remain red, and the blue car is going to remain, or is going to change to yellow. That's what we'd see. I'll go ahead and run this real quick. So let's do that. Oh, I don't even remember what I called this thing. I probably just called it X. We'll go with that. Nope, that was not it. Excuse me. Oh, functions. That makes sense. I just didn't see that there. Okay. So we're printing out, there's red car, its color is red. Here's blue car, its color is yellow. And I know I'm going into kind of an inane amount of detail to describe that these things are different, but people get confused by this. So we're going to do something else. We're going to say that the blue car is also red, and that we're going to change the color of the blue car to blue. That sounds more reasonable, right? So I saved that. I'm going to run it again. And as you can see, only the color of the one car changed. So this is important, especially because we often will have functions inside of functions. All modern languages that I'm aware of allow functions inside of functions. So I'll give you another example here. We're going to go ahead and add what we would call a method. It's a special type of function that exists on an object. So we're going to give this a special method called toString, and we're going to return, we'll use a template string for this. No, I don't want to use a template string. I don't want to have to explain that. We'll just say make is car.make plus model is car.model plus color is, car.color. And what I'm doing here is I'm just concatenating a string together. So we have make is going to get the make, so it's going to be make : space Honda. You know, you'll see this in just a second. But hopefully that in of itself is obvious enough, makes sense. All right, gearbox plus car.gearbox. Now, this toString function is just, we could maybe make it even a little bit better, but it's just when we go to print this, let's say it's a web application or it's a point of sale application, and we need to be able to print out the invoice of the car and we need to list all of its details. Maybe this is the line item for the car, right? So let me go ahead and run this. Oh, whoops. And we need to use that function. So now I'm going to get rid of that. And instead, I'm going to call toString. There. So we're going to call the method redcar.toString. I wonder why my autocomplete is messing up right now. Okay. toString unexpected identifier. Looks like I forgot a comma somewhere. Yes, I did. Okay. So fix the comma. We'll run this again. There we are. So we call this a method. Most people still just call it a function, but technically it's a method. And what's special about a method is that it is a function that exists on an object. It could be a class object or it could be a non-class object. They're pretty much the same thing. But anyway, and it has the information about the object accessible to it. So every single time I call the redcar function, which I'll just call it a couple times here, or the toString function, I'm going to get back the same thing, even though I created a blue car. So let's go back and look at this. So I created this function here when the car was red, and then I came back and I created, so this one runs and we get a red car, and then this one runs and we got another red car, but let's change that back to blue, or we could just leave it empty and then it would become black. But in any case, whoa, that's not what I wanted to do. I undid that. Okay. This function has a different copy just like the other ones does. And the copy of the function that the red car has access to the car that is the red car. And the function that the blue car has access to a variable that's named car, but that isn't shared among all the copies of the function. Each copy of the function, when it runs, gets its own specific copy of the car. And so that's why we can have the red car, red car, red car, red car, and then the blue car we'll put here and see what color it ends up being. Excuse me. And we can see, there we go. That's blue. And then I know, this is redundant, but I'm going to switch it back to red. So now we're going to have, red car, blue car. So that's essentially what a function is you can think of it like one of those Russian, I forget the name of them. I call them matryoshka dolls, but I think they have a different name because I think matryoshka just means grandmother or something like that. But anyway. Babushka, that's grandma. Babushka dolls, matryoshka dolls. Anyway, the dolls where they have the doll inside the doll inside the doll inside the doll. That's kind of what this scenario is like. Every function inside of a function is its own copy of its function that just exists in that function. It's nested. And each time you call the function, you get a different copy. So I hope that maybe sheds some light for those of you that have been a little bit confused about functions and maybe you've heard the word closures. We basically just explained what a closure is as well. There are old languages that do not operate this way. There are languages in which the variable is shared between the functions, and if you were to copy or if you were to call the function and you change the variable, it would change it for all the functions. This is not desirable. But there are some old languages that did behave that way. And I think that's why some people get tripped up, is maybe they're coming across old material or whatever. Anyway, I've got to get going. You have the best sleep ever, as I am going to try to do soon. And I will catch you later.